All right, I want to do some of Chapter 16 extension problems before I get you going on your pages 40 to 43. So this is page 35, but I have done some of these problems already. So if we'll take a look at, we've already done problem 1 and 2 somewhere else in the packet, so I'm going to skip over those because I don't really want to go over a lot of that. See, for example, yesterday we had done this problem where we were seeing what's the probability you're going to be paying $227 or more on the repairs. So we had talked about that yesterday in the notes that we had done. And so I actually want to do just the two problems that are on page 36 before I get you going on your assignment. All right, so here we go. Number 4 on page 36. Yesterday on the homework chapter 16 part 1 we found that my expected allowance for each Saturday that I go to my grandmother Podsednik's was $5.60 with a standard deviation of 144. I actually think that it was supposed to be 1.2, but let's just go with these numbers here since I already have the computation done. So what's the probability that I will make more than $7.50 on average when I go to my grandmother Podsednik's house? So here, this is a continuous function because we are talking about these average values. So my average was at 560, and I think that the standard deviation was supposed to be 1.2, but I had obviously done this key with a wrong standard deviation, but we'll go with that. So my x value is $7.50. So I'm going to find my z-score for x minus the mean over the standard deviation, and I get a z-score of 1.32. And then to find that probability of me getting that much or more, I want to see how well am I going to get, or how much am I going to get from my grandmother Podsednik. So that much or more, I'm going to norm CDF from that value, that z-score of 1.32 to 99. And so then that gives me 0.0936. So there's about a 9.36% chance that I'd make more than $7.50 on average, okay, on the Saturdays that I go to my grandmother Podsednik's house. So not real likely. I mean, maybe some, but not crazy. Now, this is a problem. This is the key problem that I really wanted to focus on. All right, this one's going to take you using your brain. This one also shows up on the warm-up and on the quiz. So let's really hone in on this problem. Here we go. The last question on the homework talked about the difference between my brother's allowance and mine. And so I think that the actual standard deviation was 233 that you had gotten yesterday. But apparently I say on here that it was 246, so let's go with that just so that my computation I have here is already correct. But I do believe yesterday when you did this problem it was actually $2.33 for the standard deviation. All right, so here we go. So it was expected that my brother will make about $2.60 more than me on average from our parents with that standard deviation of $2.46. Okay, so here is where we average. Okay, so remember that this is a chart of James minus Mary. Okay, so this is an allowance chart of the difference between, so James minus Mary. That's actually really important that you kind of know which way you are subtracting. So on average, this number 260 says that he is making $2.60 more than I am. All right. So, of course, all of the ones above 0, here's the break-even point of an x value of 0. That means he and I make the same amount on average. Well, over here on this side, of course, where it is positive, in this section over here, James is making more than me because this subtraction is a positive number. and James minus Mary is a positive number, so he makes more. But notice over here on the left, if you subtract James minus Mary and it equals a negative number, then that means Mary makes more. So over here to the left of the 0, so you have to just pay attention to which one is which when who makes more. So over here on the left is going to be the area I'm looking for, because it says, what's the probability that James and I will average the same amount in a week, or that I may even make more than him? Okay, so that's at 0, or the subtraction between the two is negative because I am making more. All right, so once you get that set up, the rest of it is pretty straightforward to follow. So breaking even is an x value of 0. So 0 minus the mean over the standard deviation, and I had it incorrect, 2.46, okay, is the z-score at that spot. So I had gotten a z-score of negative 1.057. I guess for some reason I was going to 3 decimal places. And I want a norm CDF that from negative 99 to negative 1.057. Okay, and then that comes out to 0.145. So there's about a 14.5% chance that he and I will average the same amount of allowance from our parents, or that I would make more than he on that average difference. Okay? All right, so getting that set up is critical, knowing, and probably the most important part of that is this thing right here, paying attention to which way you subtract. So you have to write that down. All right, so let's go on to this next page which is page 39. Actually, I think maybe 40 is where I want you to start. Page 40 is where I want you to start today. And so I think it was number 12. Yes, I think it was number 12 where you are starting, okay? So number 12, page 40 is where I want you to start today. Page 40, number 12. And what I actually would like for you to do is save, you can do the part C's. Here I have the part C. It's one of those normal model ones, okay? So you're welcome to do the part C's, 13C. And, but this number 14, I will go ahead and let's pause this video. So do numbers 12 and 13, and then start number 14. But I'm going to pause the video. I'll come back on here, and I'll go through 14 with you. So we'll go ahead and pause right now, and whenever everybody's pretty much done with 12 and 13, we'll go on to 14. But by the way, your homework will be through page 43. That goes through the warm-up, because you will be taking home the Chapter 16 quiz for homework. All right, so let's go over number 14. I hope that you have done A and B. I think that you can do those ones. So here we are wanting to know the difference between the viscosity of those two liquids, type Q and type W. So we had the average for Q and standard deviation for Q, the average for W, and the standard deviation for W. So first we did our little subtraction. Okay, and you know that subtraction happens like normal, so we got that from the mean of the Q, take away the, oh, looky here, it looks as though what I chose to do was do W minus Q, because it was kind of natural to have positive numbers that way. So it looks as though I subtracted W minus Q, and I got an average of 4 seconds from the 14 minus 10. Now, then I need to keep that subtraction the same direction. But the standard deviation for the subtraction of W minus Q, remember, standard deviation is special. you have to go through that Pythagorean theorem of statistics, and it is the 3 squared and the 2 squared, and this is still addition in the middle, because even though we are subtracting, our uncertainty still grows. So we have a mean difference of 4 and a standard deviation difference of 3.61. I hope that that's right, since I've obviously been having some issues with those being right on the other page. But let's go to the setup down here. All right, so find the probability that type Q oil would actually be slower than type W oil. Okay, so between the lengths of time that it takes to run through the tube. Okay, so here we go. So I first have to think, which way is this thing subtracting? And the way that I subtracted was W minus Q. All right, so that's really the first thing that you have got to think of in your mind. W minus Q. And so I know that when I do W minus Q, it averages this 4 seconds. So W is taking longer time than Q. All right, so W takes longer over here on this section of 0, because at 0 they break even and W equals Q. Here at 0, W equals Q. So over here, W takes longer, because W minus Q is a positive number. Over here, W minus Q is a negative number, which means Q's value is larger. So I guess Q would take longer time. All right, so which were they asking for? Draw the normal curve for the difference between the lengths of times and shade the area of the curve where type Q takes longer. All right, so this is what I am wanting to know. What proportion of time does type oil Q take longer? So therefore, my X value is 0. That's where they equaled each other. X minus the mean over the standard deviation is the z-score at that spot. So I'm finding the z-score at that being 0. And that is a negative 1.11. And since I want the area where Q takes longer, I want to go less than that. So I'm norm CDFing that from negative 99 up to negative 1.11, and that's 0.3133. So there's about a 13.33% chance that Q oil is taking more time than the Q oil or W. Okay, the Q oil is taking more time, or I guess is slower. All right. So you really need to kind of put some thought, your brain power into that, because there's a few of those on the warm-up. So now you should be doing the warm-up, which I believe is pages 42 and 43. And you come across that here. You come across the dog plus the cat and the dog minus the cat. Just by the way, I had chose on my subtraction on page 43. Part F, I did, I believe, cat minus dog, because I guess the cats were naturally a bigger number than the dog. You could do it the other way, but just FYI, I had chosen cat minus the dog. I like to put the larger number first, and it does not matter which way you go. You might just get the mirror image. All right, so you're going to pause this video and let you do your warm-up, and then I will go through the answers real quickly of this warm-up for you to check right at the end of class as a quick check to make sure you've done that. Now, I will leave the full video of going over the warm-up in great detail on the plan book or on your app that you can get to, and you could watch that video if you need to tonight. But otherwise, you're going to take home quiz 16, and you will turn that in to me tomorrow. Okay, here's the quick answers to your Chapter 16 warm-up to do a self-check. A is 2.95 emails. B is a standard deviation of 1.32 emails. So then part C is going through the transformation of it's taking 2 minutes per email. So I'm going from emails into minutes. I'm multiplying by 2. That means that the mean gets multiplied by 2 and the standard deviation gets multiplied by 2. So both C and D are multiplied by 2. All right, E is going through the transformation of 3 minutes to boot up the computer plus the 2 minutes per email. So that means that the mean is affected by the addition portion and the multiplication portion. However, the standard deviation is not affected by the 3 plus portion. It still stayed the same. It was just the 2 times the standard deviation of emails. So that's 2.64 minutes still. All right, G asked for the probability that he spends more than 15 minutes on average answering these. So that's where your mean is the 8.9. Your X value is 15, so you find a Z-score, X minus the mean over the standard deviation, a Z-score of 2.31. And then when you norm CDF, your area is 0.01044. So that's just about a 1% chance that he's going to have to spend more than 15 minutes on average answering those emails. All right, the next page, we have got number 2. So this is the dog and the cat. So the average for the dog and the cat. See, we have 2 variables that we are adding together. 2 separate variables. The variables, the mean and standard deviation for dog and the mean and standard deviation for cat. So the means add together like normal. So on average, you expect to spend $220. And the standard deviation has to go through the Pythagorean theorem of statistics with the addition. And so therefore, that is $46.10. So, on average, what's the probability that you will spend less than $140 total between the 2, dog and cat? So that's my X value of $140. So I do X minus the mean over the standard deviation is a Z-score of negative 1.74. I want to spend less than that. So that is norm CDF from negative 99 to that. That's a 4.1% chance that my total care for my dog and cat will be less than $140. All right, now we go to the difference. So this is the subtraction. And again, I guess I had chosen to do subtraction with cat first because the cat was a bigger number and I just kind of like to do those things that way. So I had done 120 minus 100. So the cat's going to cost more than the dog, on average, $20. So this is the cat, $20 more than the dog. Those pesky cats. All right. With the standard deviation, again, you have to go through the Pythagorean theorem of statistics. And what I'm seeing, if you note on this, is that even though this is about a difference, the Pythagorean theorem still adds. So this is the same standard deviation that you got previously in the problem about adding the cat and dog care together. Now here comes this guy here. If you find what is the probability that the medical expenses are higher for the dog than the cat? So I drew my picture here. First of all, I had to really hone in on the fact that this is about cat minus dog. So the positive numbers, so 0 is where cat and dog equal each other. Okay, the mean is this $20. So the mean is $20. So over here to the left is 0. That is where the cat and the dog care are equal. So let's see, if I'm doing cat minus dog, these positive numbers over here are when cat is bigger or costs more. And these negative numbers over here are when the dog costs more. Because you do cat minus dog and you get a negative number, that means the dog cost more. So what am I looking for here? What's the probability the medical expenses are higher for the dog? So I want this area over here to the left of my break-even point. So I find the location of that break-even point, z equals 0 minus 20 over that standard deviation of 46.10, that's negative 0.43. So then that norm CDF's that there's about a 33% chance that my dog will average more than my cat. But otherwise, I'm expecting the cat to cost more than the dog. All right, so take home your quiz, bring that back for me tomorrow. I'll stamp everything and take up your quiz. We'll start chapter 17 tomorrow.